contact Oscar Mike 4 Whiskey Mike. Oscar Mike 4 Whiskey Mexico. Contact. Pick your contact Oscar Mike 4 Whiskey Mike. Oscar Mike 4 Whiskey Mexico. Contact. Pick your contact Oscar Mike 4 Whiskey Mike. Oscar Mike 4 Whiskey Mexico. Contact.
Alright, back on. So what we're doing this morning is carriage assembly, sorting that out. So to sort that out, we've got to finish off the wheels and the pins and be able to move it back and forth and work out sizes, gantry, and how we're going to get this size that we want in the case, if at all we can even use that case, or do we make our own case? Because I don't like the idea of all the electronics and high tension being outside the box. And if you do that, you're going to have to run the high tension cable into the box from outside, into the case from outside. So we might have to rethink this. We might have to put this one to one side and create the bed that we want, the ideal bed first, a workable bed, and then build round it. Might make sense, seeing as we've got a lot of this extruded aluminium, enough to do the gantry and maybe enough to do the structure to bolt panels to it. So I'd rather do that than just rip all this stuff out of here and get the steel out just to make enough space just to make a box that contains it. Why not just put your laser and all your bits from the outside onto, create the internal structure, mount it all to this new extruded aluminium gantry and get rid of this and create plastics panels to enclose it. I've actually got some black plastic sheet and white plastic sheet, so maybe we could just screw it to this and make a structure out of this stuff if we've got enough. So anyway, what we're going to do today is design the gantry and the mechanism and the size we want. And the size I'd like to do is 700 by 500 or 600, based on one of the commercially available laser engravers that you can get, that I wanted to buy but I didn't want to spend £2 on, if you know what I mean. Anyway, so and let's get on with it. Right, so we modelled on the first episode. Now we haven't gone away from the Amiga stuff. This is so we can create the Amiga stuff. I need to get rid of one problem at a time. So I've now been and got another one of these. So I've got 3 of them. They're okay for small plastics, but they're a bit elaborate. They're very elaborate, so what you get, you end up with exhaust fans on them, water pipes in and out, CO2, cooling, you need all sorts of stuff. So either way you're going to need all that, but it doesn't sit inside the box. That's where your laser tube goes. But most of it, you get your power supply in the box and your laser tube. So if we take the power supply out of the box, the laser tube is still in the box, is really the only thing in there. And the fact that you've got a containment to extract the fumes. Now I've seen a commercial laser cutter that was cut in leather. Now the leather garment you can't put your leather garment on here. You couldn't get it in there. So you're looking at a massive table and a gantry system that moves the laser sits on the back. The laser sits fixed at the back, I would imagine, unless it moves with the gantry. No, it'd have to stay with it. Yeah, it would stay with it, of course. So imagine a laser fastened to the gantry, not the gantry, the rest of the structure of the box, which is not a box, it's more of this stuff bolted together. I quite like the idea of that, and it's cheap now, it's quite cheap compared to buying one of these. So as far as I can see, this only acts as a screen so you can vacuum out the stuff. Now what about if you had a powerful extraction system sat over the work area? You know, like a funnel, like they do when they're cooking. You know, when they're cooking, they have a hood, an extractor fan, sucking all the time while they're cooking in the takeaways. They're creating their curries, and they're always flambeing and burning oil, and there's garlic and chili fumes. It needs to be gone away. Well, there's one thing with food fumes, another against toxic plastic fumes, I suppose. Anyway, let's put this away for a bit and create the gantry and the wheels and the mechanism. Find out what size we need. Now I think we need 700 by 500. I'm going to check that in a minute. So what we're going to do is first hide this case. So that's the case. And right, so first what we're going to do is put these under, we cut them, and then right, actually no, we're not going to cut them, we're going to undo the cut, undo close, undo cut. Right, so we're going to make this, put all these into the case. That one is already in the case. So anyway, we'll do that. Then we can hide the case. Right, so hide the case. This is just some messing around I was doing. So first thing to do is check. Let's check this available. I want to check the one I was gonna get. Laser cutter. Let's try to find it again. Right, okay. Let's try and find it. You never find it when you want it. What is going on? Pre-owned laser cut. Oh my god. Just seen something. Where's it at? Manchester. Industrial chiller. What is going on here? Hold on a second. Right, there's someone selling one for a grand. With a 700 by 500 cutting area. That is, and a water chiller with it. My god. That'll save such a lot of problems. Buy it now. Tempting, isn't it? Very tempting. Literally, I would get removed from my house if I did that. That's a shame. That's all done for you. Yeah. That is a shame. That's nice. Anyway, we're making our own. We're making our own. So it is a 500 by 700. So that's all we wanted to find out. If I hadn't have, I could sell what I got and then have enough money to buy that. But anyway, we're going down this route now for some reason. That's pretty cheap. Drive to Manchester and pick it up. Yeah. It's half the price. But you can get them on AliExpress for that price, but then you got to wait and all that kind of stuff. And you don't know if this one, the end of life, you don't know if it's worn out. No idea how much use it's had. That's a big problem. And I'd rather make one that was modular, that you can just... So there's the new version of it. You've still got that one, last one. It's not quite the same version, almost similar. So, yeah. Anyway, we'll carry on with what we're doing. Because a lot of it's smoke and mirrors. It's here's another one. 800 quid. Look, there's loads of them. Yeah, 1000 watt, 100 watt. Anyway, we're going to keep what we got. Let's keep what we got. Because I think it's all a bit of a compromise, isn't it? So what we don't want is to get compromised by this internal size of this case, having to restrict what we can cut. It's not what we're after. And you could say you could cut the case in half, stretch it, add new panels, weld it, grind it, paint it. What a lot of trouble, eh? So it's got me thinking now about that one that's for £1,000. Water cooler, go and pick it up, job done, and get on with making stuff. And what if it's got a fault? Anyway, we're making our own because we've got the... Let's make our own. Stop looking at stuff. So, the ones you can get... what's this guy doing? Right, so... So what we've got to work out, if we make it, we've got to be able to move it around. It should be quite light actually. Maybe lighter out of plastic. We've bought the materials, so we might as well build it. Otherwise we scrap these videos, go and buy that one, go and fetch it, and hope for the best. It comes with a water chiller. Or just, I don't know. Going back to that again. We've got all the bits, so let's just make it. Let's just make it. Right, so let's model the... We want to finish this off. Let's model the wheels and the bolts. Let's just do that. So let's create a wheel. I just so happen to have a wheel here, so I've got to model that one now. Anyway, I'm going to carry on. I'm going to go a bit quiet and just model it, because I'd literally be here talking forever and never do anything. Alright, so we're looking at 24. The wheel's 24. Excuse me, so let's just make a wheel.
Oscar Mike 100, Italy Alpha Radio United Kansas.
12. So there's your wheel. And
Oscar Mike 100,
the width
Italy
of the
Alpha
wheel.
Radio United Kansas.
What's the width of it?
Oscar Mike 100, Italy Alpha Radio United
11
Kansas.
mil.
Oscar Mike 100,
Right, it's
Italy
11
Alpha
mil.
Radio United Kansas.
11 mil. Oh, let's change him. He's just a repetitive robot, that one. Right, let's find someone else, because this is... Nothing on it. Just noise. I'll leave it on there, see if anyone shows up. Right. I'm going to have to take the glasses off to look at this. Let's model the wheel. We make our own. And at least if we make our own, you can be built up out of pieces and bought and built bits at a time. I must be mad. Why don't I just go and buy one? I have no idea. Right, so we've got 5 mil inner ID. Let's do that one. So what we'll do, we'll make it a component to start with. At least we can go into it, hide the rest of the model and zoom in and work on it that way. Right, okay, let's put in 2.5. There's the bore, and it's got another thing that is, how big is that? How big is that? 1 point, that's 1 mil. .5 mil. So we want a thing 1.5 out there, that's your shell. Then you've got another one which is also, what is that? It's difficult. Is it 1 mil? Let's say 1 mil. So another one, 1 mil. And then we have even another one after that, which is a 1.5 mil. So another one at 1.5 mil. Then we have the flat wheel, which is 2 mil. .9. I'd say 2 mil. Another one at 2 mil. And we have a bevel. Oh, something doesn't look quite right. Something doesn't look quite right. Oh, it might be. Could be. Let's have a look. So go from there to there. It's about 2 mil. Let's see if we've got 2 mil left here. 3.5. Right, it's not quite right, so go from there to there. 17 mil. Just make sure we got that. $19 mil. Something wasn't quite right. I think I know what it was. Let's have a look. So this between there and there is 1.5 mil. Right, is that 1.5 mil? Yes, it is. Then you got there's a space. And you got 1.5 mil, and you got a little gap of about 0.5 mil. Right, let's try again. So you got that, and you got that, and you've got from there you've got a little bit of a inner, outer, and you got a little bit of space. Oh. Right, okay. So let's get rid of that one. So you got there, then you've got a little bit of a thing like that, 0.25. Then you've got 1.5 mil here. No, that's the wrong one. 1.5. And you've got another gap of looks like 0.5, 0.75. Then you've got a 1.5, and then you've got another gap of 0.5, 0.25, and then you've got a gap of whatever that is. .75, 1.75, and then you should end up with 2 mil from. Yeah, that's it. That's the one. Okay, so that's the geometry for the wheel. Right. Let's just save it. So, first thing we can do is go down like this. Then we want a little bit of an indent here. Not a lot, just enough. 0.25. No, it's gone the wrong way. That keeps going up for some reason. Let's go in. Wants to go up, not down. Oh, there you go. 0.25, there you go. Right, and then you've got your thickness there, and you've got another bit of a gap here that's another 0.25. Okay, then you got a solid bit, and you got another gap of 0.25. Okay, and then you've got this outer bezel. You've got your flat, and then your outer bezel has to drop. So we have to drop this bezel. Let's measure the width of the wheel. It looks like 6.5 mil. 6.5. So let's just do a little bit of a line here. We've got 10 mil. No, we've got 11 mil. So 6.5. Well, let's just go halfway. 5.5. And let's go. Actually, let's go up. 6.5, 3.25. And 3.25. Okay, so that's why can't I grab that? Anyway, we'll leave that there. So I've got to grab the side. I've got to grab this. I've got to hold on to that. I've got to grab it. I've got to push it down to there, like that. Let's come out and have a look at it. Yeah, looks okay. And I've got to do the same so we can grab. I should be able to grab that out of there and delete it, yeah. Now we've got to do I want the same down here. I want all this again. Right, so I want all this again. Yeah, I want that again there. So, right, it's going to be a bit awkward to do. I'll tell you what, we'll just measure it. So we've got our 5 mil, 5 mil. Then we've got our 1.5, then our point. Then we've got our 1.5. Then we've got our 0.75. Then we've got our 1.5. I'm never going to remember all that. So let's just go upside down. Right, I don't know why I'm doing it this way when I could just do that. Right, let's do it again. So we've got our 5 mil. And we know this is 1.5. Then we've got our 0.25. And I don't know what it is after that. So I can't remember. Then we've got our 1.5. Then we've got our 0.75. Um, 1.5. Then we've got our, what's going on here? 0.75. Then we've got what? We've got 1.5, and we got our 0.25, and then we got our 1.75. So let's try again. 1.5, and we've got, why would it auto select? And we've got our 0.25. I think, yeah. Then we've got our 1.75. Then we should have our 2. Yeah. So we can do that again. So push that down. 0.25. 0.25. 0.25. Then we want to grab this and pull it down to wherever that mark is there. Just like that. Get rid of that now. Okay, so we've got our wheel. Should have our wheel now. Yeah, we've got our wheel. Let's colour the wheel. Let's just save it. Looks a nice wheel actually. (6:25) in the morning on a Sunday. Dead quiet, nothing going on. Let's colour it with corrugated shiny. Okay, that'll do. Right, so let's have a look at the wheel again. We've got a slightly grey colour. I suppose we could shine it like that. Then we want a black area, then another shiny bit. Okay, that's turning out okay. Okay, and let's do the dark areas. A little bit darker areas. Let's just go down here. I'd say it's sort of like this colour. And that could be sort of that colour as well, sort of, and so can that be. Then we want a synthetic looking colour maybe, or plastic. We'll keep it this colour, so a bit darker. Looks a bit too dark. That's better. Right, okay. Let's carry on with this side. Right, we're doing alright. So, I think it's that colour. It probably might be that colour. Metal. Okay. Oh, hang on. We've left out a bit of a black colour here. Left out the dark colour, which is that one. Needs to go there. And also the other side. Morning. Right, so there's our wheel. To scale, modelled, exactly as we want it. Right, so we need something else to go with it now. We need a spacer. So we'll do a spacer. The spacer needs to be, I think it's 10mm. Not sure the size actually. Let's just see what we've got here. I think it's something like this size. It's 10mm by 10mm, I think it is. So maybe the spacer just goes like that. Yeah, 8mm. Don't know. Tell you what, we'll make it 10mm. We'll just make it separately. We'll do it here. So we'll go. First, it's going to be 10mm. So 5mm. Then it's going to have a 5mm hole in it. And Oh, actually, we've done that wrong order. So we need to bring that up like that to 10 mil. And put a hole in it. .5. And what have we got here? Wise 2.5 mil. It's probably right. Don't know if it's that wide. Anyway, we can just pretend it is. And this is going to be a steel looking colour. It's a spacer after all. Okay. So we can always alter that if we need to. Make a component. Done. Oh, we've crashed. Wonder why we crashed. Hopefully it won't take too long to escape because there's not much that. Well, there's a bit of geometry, but not as much as the case. Rightio, let's run it up again. Don't ask me why it crashed, just crashed, it's stupid. Alright, let's try that again. Seen an auto save, so we didn't lose anything. Okay, did we finish painting it? Not sure, looks like we did. Yeah, so we're just going to put that now. Move that on to here. Oh, we need to look at it in a different way. So we can zoom in. Place it on there. Right, so that's our wheel and spacer. Now we're going to need need to look at one actually. Can't remember how it's done now. So the nut is on the back. Right, fair play. So we need an M5 nut. An M5 nut. Don't know if I've done an M5 nut before. So let's just do an M5 nut then, why not? Hex nut, need to know the size of it. Let's just have a look at the size of an M5 nut. If I can get the calipers on it. Oops, fell on. Right, 8.5. Is that real? Is it real? No. It's very difficult to work out an M5 nut. Let's say it's 7.5. 7.5, and it's about how tall? 4.5 tall. 7.5 by 4.5. Right. Okay. So 7.5 divided by 2, 3.75. 3.75. Okay, and we said it was about 4.5 tall. 4.5 tall. Maybe a circle on it, which needs to be 2.5. And then we need another circle on it that needs to go 0.5, say. and we need to bring down this. Let's just have a look at that. It's not a lot, it's only 1 mil. Bring it down 1 mil. Okay, push that down to the bottom. Yeah, now we need to grab this and bring it down to there. That'll do. Right, okay, so we've got that, and oh, no, we want to stop that, undo that. We've got a bit of a ring to do, like that, 0.25, and then we need to grab this and bring it down to, does it all the way down? Yeah, go all the way down. Okay, there's our nut. Let's just make it the right. Oh no, hang on. No. Undo. Right, so yeah, there's something wrong here. Undo, offset, undo, push pull, undo. Right, so this one's not quite. Needs to go out further. That one does. Needs to go out further, all the way to there. And this one needs to go 0.25. Right, then we need to, I don't know if we can push this down. Now, maybe we can do it if we do, like, probably can do 1 mil. 1 mil, 1 mil, 1 mil. Oh, it's done the. Why has it done all the rest? Right, okay. Now we need to bring this down, if it'll let us. Let's see if it'll let us do it now. It's all in bits. It has. It's let us. Right, so yeah, hang on. Right. So what we need to do is we need to bring that down. It needs to be brought down, sort of. I suppose you could just bring it down to there. Colour a bit of, yeah, colour the, so colour that blue colour, something like this, and the steel. Then we need to bring this down to the bottom. Okay, so we need a line there. Right, we need that line. Copy. I need to push it down to there. Is that right? No. Right, okay, let's try it from the other side. See if we can bring it down to there. Right, okay, that's what we wanted, yeah. That's it, sort of like that, yeah. Okay, so we need a steel colour now for the all this lot. Steel colour, There you go. Right, okay, is that the lot? Does that look steel? Yeah, probably. Yeah. Right, okay. Have we got everything done? I think we got everything done. Right, that'll do. Okay, so in reality the nut isn't square like that, it's rounded. But are we going to go to that extreme? Do we need to do that? See, the whole thing, can that be brought down? No, that's going to wreck it. We'll leave it at that. That's close enough for a nut. So let's make that a component. Right, I'll stick that on top of here. Let's grab it by the horns and just place it on. Right, hang on. Doesn't want to go on? Why not? Why doesn't it want to go on? What is the matter with this? It's weird. Is it not in the same orientation? What is going on? Right, I'll have to do it a different way. I'll have to grab it by the middle and then reference this middle. Right, it'll have to go like that. Okay, so that's one way of doing it. Right, so we've got that, so just need the bolt now. Need the bolt. So we've got our nuts, and we just need the hex bolt. So let's make a hex bolt. It's going to be easier this time because they're not nailed, they're just smooth ones. Yeah, they're smooth ones. Let's get the size of that. 7.62. 7.62. Let's just make a bolt. Alright, that's the component. Let's do it the right way up. Alright, it's round. 7.62 is 3. Let's just say it's 7.5. Now 7.62. That's where I need the calculator now because I can't work the fractions out. 7.62 divided by 2. 6 what? 7.62 minus 2. No. 7.62 divided by 2. 381. So 3.81. And then there's a hex socket in the middle, the size of which is 4.5. 4.5. So we want 2.25. 2.25. That's your socket. And it goes down. How far does it go down? It goes down about There's a depth gauge on this, isn't there? 2.25. So it goes down. Oh, we can't do that yet. Hang on. We need the width of that. Width of that. It's hard to find. The depth of it. 5 mil. So we've got 5 mil. So we need to take this off a minute. Cut that out. Push that down 5 mil. Paste it in place. And push that down. I can't remember. Was it 2.5? $3 mil. 3 mil it goes down. So push it down 3 mil. Okay. Turn it round and we want a 5 mil thread on it. And it needs to be, I know what size these are. So I was trying to source them. 30 mil long. Let's give it a slightly better look. Let's say 0.5. Let's go down 0.25. That's it. Okay. We've got, looks a bit weird. Why does that look smaller than the scale of that? Something's not right. Don't know. Let's have a look. 7.62. Okay, that's what it is. Right. Let's make that into a component. And we'll I need to stick that over there, but it needs to be the thickness of the plastic, whatever. There's a discrepancy in the thickness of the plastic. It's not going to let me. Oh, it is. Go on, go over. It won't go. It did and it won't. Come on. Right, let's do it a different way. Let's grab it by the middle. Come on, you can do it. Okay, we'll have to go X-ray. Is that it? What the hell? No, it's nowhere near. There's too many lines of geometry. Too many lines of geometry. Is that it? Okay. It's close. You got the thickness of the plastic. Right, so how much plastic thickness have we got here? Hopefully we've got 6 mil. 4.5 mil. 4.5 mil. Maybe that isn't 10 mil then. That spacer. I think we need to have a look at that spacer. Just save that. Let's have a look. Just got to open up not AliExpress, Amazon. Right, let's open up Amazon. Here's Amazon. Right, so V wheel spacer. Right, there were the ones there. They're eccentric bush. I don't want to use them. I just want the size of the spacer. Height 6mm. Height is 6mm. Right, could they be 6mm? Where are they? You can get them separate. You can actually buy them separate. I've seen them. Where are they? Why isn't it showing me the spacer on its own? There's an ambiguity between the size. It's not. It's going to play. It's not right, is it? Why can't I get that size? The size of that. Where's the spec? Oh god, all the information but not the one you want. Size, inner diameter, height. So are they both this? Maybe they're both 6mm. 79mm with a 10mm wrench. Right, it's 6mm. Let's just say the 6mm. Let's say the 6mm. That's why it looks weird, because it's too long. That looks more like it. And while we're here, we might as well make it look more appealing. No, that's not it. Okay, that's it. I don't know why I'm doing all these detail, because there's no need for it, really. But if you're going to do it, you might as well do it. Okay, so we've got the right size now. So it should give us something like the size we want, as long as we can get 6mm plastic in there. What's all this jagged bit here? Oh, right, okay, so we should be able to 8.5, so we can get 5mm, 6mm, and so what we want to do is move the whole thing up. That and that needs to move up by 2.5mm. That'll give us a 6mm plastic. So on a 30mm we do get this extra bit. Now I don't get that on the one behind me, because this plastic's thicker. This original plastic is 7.5 mil. 7.5 mil, so that means this should be what, 1.5 mil. 2.5 mil. Okay. Anyway, I'm going to be using 6 mil plastic instead of 7.5, 8 mil. So it is going to stick out a little bit. So I suppose we could just, to make it neater. There's no washer on there. I don't know why it doesn't have a washer. Why doesn't that have a washer? There's no washer. Suppose it could do. We'll leave that as it is because it could have a washer. Unless because it binds. If you have a washer on it, it binds across. Don't know. Let's have a look. So the middle stays. Yeah, suppose it might bind. Anyway, we'll leave it as it is because it serves our purpose. Let's just colour this. Let's colour this. Okay, we're done. The only thing we're not done is it's not square, is it? It's a little bit round, so what we need to do is just give it a bit of a 0.25 and grab this and move it down. No, that's too much. Oh, it's crashed. Oh dear. Crashed. Let's wait for it to crash. We fooled it. We upset its algorithm. Right, let's try again. Some people use Blender. I did try Blender once. Don't know. We haven't lost much anyway. Alright, so it worked that time. Suppose we need the same one here as well. Otherwise that's going to look weird. Try and get it centered on the screen. What's it doing now? That's it. I'm not going to do threads. I don't do thread. I don't want to model a thread. I don't care about the thread. Anyway, so that's the wheel. These will all have edges as well, but I'm not bothered about that. Right. Looks weird like that, so anyway, I'll leave it like that. It's because that looks horrible there, like that. Oh well. Never mind. Right, let's make it a group. Okay. Let's get it on to the carriage. We need to grab it by something. So we're going to hold that there. We're going to move this like that. And grab it by the middle. If we can get it by the middle. Yeah, we can grab it by the middle. Always grab them by the middle. Right, let's put it up this one. Right, it's a recipe for crashing, I think. Oh, yeah, obviously that's got to sit in the V. Right, why have we got too much space? We need to come over a bit. Let's come over a bit. Right, that's lovely. Okay, so we've got not much gap down here when the steel's in the right place. I suppose we ought to bring the whole thing over and that and push it into the V. Push it into the V. And a little bit more. Um, 0.25 and a bit more. Yeah, that's about it. So we're in the V. We're a bit squashed because we need to go up a bit. We've got a little bit of a gap down the side, so we need to go up a tiny bit. Can we go up? And again. What's that like? Close. A little bit more up. That's not bad actually, we'll leave it like that. It's not bad. Let's have a look at it. Oh yeah, I'm liking it. So we've got the space at the side to run up and down. Right, so now we need 4 more wheels. Let's just make this the right way around colour wise. It's going to be made out of clear polycarbonate, so that's good so we can see what's going on inside it. So reverse the face. Right, that's better. I suppose we better get all these as well and reverse all these faces as well. Okay. So, have we done them all? I think so. Sort of, there's always a few more. Okay, is that the lot? That's the right. Everything is right now. No, not quite. Look. Not quite. Now we've got it, haven't we? That's all the right way around. It's going to be made out of clear polycarbonate. So we'll leave it for that. Leave it at that for now. We'll sort the material out in a bit. So we want to know how far it is from there to there. 6.42. And how far from there to there? Hang on, what's going on here? Right, from there to the middle of this one. 64.5. And we're going to go from there to this one. Oh, where's it gone? What the hell? It's gone rogue on me. 60.5 and 64.5. Right, so I'm going to go copy this one down, move it down 60.5, and we're going to grab, oh yeah, that one and that one, and move it over 64.5. Hopefully we should now have 4 sets of wheels. Yeah, 4 sets of wheels, and do they sit nicely in? They do. Sort of. Little bit of discrepancy there. Maybe we need to... What's that like? Yeah, we just need to go up a tiny bit. So I need to grab that. They're in the right place, so we need to put that, that, that and that as a group. Oh, and that. Need to group it. I need to move the whole thing up by 0.1. Have a look at it. Zoom in here and have a look. Still got a bit of a space there, that's okay. Have we got a space on the top? Not quite a space on the top, so we need to go up another point 0.1 until we've got a bit of space on the top, or no space. That's, have we got any space? We're just touching there. What about underneath? Still not quite touching, are we? Almost. So we can just go up a little bit more. Let's just go 0.1. Right, let's see what we got now. That's not bad. How about the bottom? That'll do me. I'm liking that. Right, that's as good as it's going to get there. So all we've got to do is make sure we lock that, so that and that will be grouped. Then we want to grab that and group it, so we don't move it. Okay, so we've got our runner. Theoretically, you should be able to grab that and move it around like that. Should be able to move it around to test your range of motion. Anyway, we'll leave it there for now. Right, so now we need to build a bed. Oh, we want that again over here. Can we just flip it? I wonder if we can flip that. Let's have a look. So if we copy it, like that, and can we flip it? Flip along red axis. Yes. Yeah, we flipped it. We didn't want to turn it round, we wanted to flip it. That's right, that saved us, because it's the exact same as the one over here anyway. But there's no point keeping that when we've got that one. Right, so we want a 700mm cutting area. 700mm cutting area. And all these parts are anatomically correct. They're as they're supposed to be size wise. So it's a scale model. Right. So into that end, let's get rid of one of these a minute. So we've got that, let's copy that. I didn't know what size we'd copied it to. Can we flip that as well? Flip along red axis. Yay, we have. So we flipped it again there. Actually, we could have flipped the whole thing, couldn't we? Let's do that. Let's get rid of that, and get that, and copy it. I'm gonna move it out. Let's say 500mm, and then we're gonna flip the whole thing. Flip along the right axis. Now, how powerful is that? How powerful is that? And everything's exactly the right place. I'm loving this program. I hate this program some days. I love it in other days. It's crazy. Crazy program. How can it invoke different things? Hate and love at the same time. Right. Okay, I suppose we better just do this colouring of this one. Let's reverse the face. Let's get these faces the right colours and be done with it once and for all. These are the feet that hold it up off the floor. Right. I don't know if this is the right way of doing it. I don't know if I put it back as it was actually. No. Right, that's not right, is it? Yeah. Okay, they was already the right way, some of them. All of them, by the looks of it. Should have left it alone, I think. Right, is that it? No, not quite. Just trying to get it the right way around to start with. Okay. Right, why is all that face okay? Well, I've already done it. Don't know. Anyway. Right, so we've got them legs. It's got the little cutouts for the belt to come through. I like this construction method, it's pretty good. Right, so we've got that. Okay, we do need some screws to hold that in. I suppose we could put them in now. Does it need, do we need, yeah, do we need it on? Oh, they don't line up. Look at that. Why don't they line up? Do the legs stick up a bit? Oh yeah, they do. They do stick up. Right, so let's just sort that out then. Yeah, they do stick up a little bit. So, what have we got here? 5.18, is that right? We've got some slightly oversized there. So let's grab it by this bit here. No, we've got the whole lot. That's okay. Okay, what we got there now? Let's have a look. Yeah, that's it. That's right now. Sort of. No, there must be a discrepancy on the holes. Now, is it my discrepancy, or is it? Did I design it slightly imperfect, or have I designed my bar the wrong? Let me just find out. Let's just get into this. Let's find out what's different here. So let's say from there to there, 20 mil. Let me make sure before I start going. Just got the calipers out. You'd think it'd be 20 mil, wouldn't you? Mils there. Yeah, it's 20 mil. It is 20 mil, so that means my little thing, it did work. So I built one already. I built this already, so it did work, but it's very, 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 very slightly out. So how far out is it? So that one's okay there. So these two holes need to be moved very slightly. Or does it even matter? It still fits in. I suppose it matters. Should get that right really. Okay. How far do I need to move it by? That's what I want to find out now. Right, I've got 0.78 and I've got 0.2, so it needs to go 0.5. How can I do this? If I view in, don't hide the rest of the model, if I go into this and I grab these two and I grab that and reference that and that, that should have put everything in the correct place. Yeah, it did. That's close enough. Better now. It should have done the other one as well. Yeah, it did. Okay. Now, the only thing I didn't do is this one's too low now. So what we'll do again is we want some bolts anyway, so I'll delete this one. Let's put some bolts in here. Now I know these bolts are 20mm instead of, they're 20mm instead of alright, let's just flatten it around. They're actually 20mm. Let's use that as a reference. No, I'm going the wrong way yet. Hang on. Let's use the top as a reference. Alright, hang on. Where's the top? There. Let's use that as a reference. That's it. They're only 20mm, so we need to make that unique. Make unique and then alter its length by 10mm less. Okay. Right. So now we can use that over here. So that, hang on. Let's come out, so that's that. That's part of that. That's still its entity, so is that. No. Right, hang on then. Right, okay, that's its own thing there. Oh no, that's the wheel as well. Right, now that's its own thing. Right, let's grab it by the middle. Bring it up here. I need to be in X-ray mode for this. Try again. Is that right? Yeah. Okay. It's too far in. Need to bring it out to the surface. Is that right? Close enough. Right. Okay. So I need to cut that out now. Cut it. Come all the way out again. Right. So I'll put it in this group. So paste it in place. And we want to just find out. Oh, hang on. Just need to find out how far this is from this one. 20mm, of course it is. Right, so we want another one of them. 20mm down. And we might as well put the one in here as well. Now is that should be 20mm as well. I wonder if it is. 19.6. So we need to alter that really. Just move it over 0.4. So now we've got 20mm. That's better. Come out of there, copy another one of them, move it over 20mm. So we've got our fixings in place, ready for all that lot. I'll leave that one where it is, that's fine. Okay, so we come out of that. We've got our carriage roller. These are the wrong colours still, so we might as well make these the right colours. We're going to make them out of clear polycarbonate, so we'll come and do that. I've got to go away for a minute. Let's just create another one of these, move it over, let's say 750, just say 500 for now, and then we'll flip it, flip along the rear axis, so we've got the complete opposite, but it's still a component of this one. Right, so we should be able to do something crazy like grab that. Oh no, hang on. If you view the rest of the model, and I should be able to move that. Will that move the other one? No, it only moves one. So what we'll have to do is make that a gantry all in one when we do. Right, ignore all this lot, it's just placements. Right, so we've got this. This is exactly modelling one that we've already got. So this is one commercial one you can buy, and it's all the same. I modelled this out because I lost it. Well, I bought it missing. This was missing. So I made it out of polycarbonate. That's what it's supposed to have been like. So all this idea works. I've had this working. It's only 500 milliwatt. 500 milliwatt, that'll only cut card or paper. Won't cut thick card. 300 gram it won't cut, it'll cut smaller stuff. Anyway, I'll be back in a bit. Hello, you're back again. Right, so yeah, changing the colour of the plastic next. Transparent. So, I've got one already in a different model. We'll just make a new transparent plastic. Right, let's just do it. Right, let's just make a new one. So I want a transparent glass and mirrors. Is it that one? Translucent. I'll put it onto there. Is that going to be good enough, do you think? Keep it like that. Let's have it. Oh, you can't really tell till you've done it all. You've got to do it all first. It's awkward with that. Hang on, let's hide the rest of the model. Let's hide the rest of the model and sort this out. Not that line. Right. Keep going. It's awkward. Why don't it centre it? Oh, because it's looking at one over there. Right, we can do that as well. Hide similar components. That helps us swing around this better without worrying about, yeah, constantly having to change those depending on what you want. Right, so struggle to get them. Right, what else? What else? Is that it? No, not quite. Still a few left. Still a few surfaces left. Okay, is that it, you think? No, it's not it, look. Right, and there's still another one there, and there, and there, there, and there, and everywhere. Is that the lot? It's never the lot. It's always something else to do. Just have to swing around it till you can see. It looks like it. There's probably some down at the bottom. No. Is that? Yeah, there's one. There's one there. Is that the last of it? Is that the last? I think it is. So let's have a look at that now. Okay, so we've coloured it. It's a bit opaque still, which I found it was. So what we'll do is we'll go on to edit it, and we'll change the opacity a little bit down. Oh, that's better. I want to see what's going on ultimately. Probably about there. Okay. Is that too much? No, it's not too much. A little bit too much, maybe. Maybe too much. Can I alter this? Yeah. So it's like that. Looks like wireframe a bit. Gotta have a happy medium. I think that'll do it. No, it's a bit too less. Try that. We'll try that. Okay, so I need to colour this one as well. Let's just save that. Let's get some surfaces. In fact, you can do it from up here if you get the right amount of. Select everything like this. You can. That's all we're going to get from that. Might as well select everything else we can. Is that the lot? Certainly looks like it to me. Right, let's say it's everything. So we'll go into here and see if we can find that one. Okay. Alright. That's it. At least we can see what's going on with the belts coming through and the fixings. Yeah, it's a little bit out. Maybe we'll adjust it. Let's just adjust it. Let's give it a bit of that's too much. Maybe we give it a bit of blue. No. What about red? Less blue? Probably not. Green. Bit of red. Maybe, I don't know. You got fine control over it. Let's try to make it blue. I like the blue. Yeah, let's just leave it blue. Okay. Right, let's try the blue for a change. Okay, so we're doing all right. So what we need is some legs both ends. Let's move some of this stuff out of the way. Let's get rid of that one and that one. Move that one out of the way. Tell you what, just get rid of it. Right, so we've got our two lengths. What we need now is a gantry, and ideally I bet these aren't right either. Let's just have a look at these two. Okay, so let's measure this, because I was guessing it at the time. 20.5, slightly out. 22.5. Okay. So we need to. I had to measure this with, just guessing. So let's sort these out before we go much further. 20.5. So we need to move. Let's move this one down a bit. Alright, let's move that down. 0.5. And let's sort this out. This is 2.5 mil too far over. Let's just grab all that. .5. Let's make it right. So now we should be able to put the bar either way. We'll try that out in a bit. Also, we need to check the stepper motor part. Doesn't look quite right, does it? Right, but I've got new stepper motors, so let's just check the size of that. 31. And we've got 31. So we've got 31, 31, 31. Right, let's get a stepper motor out and try it. I'm just going to save that. And I'm going to swap over to the screen, show you some stuff that I picked up. Some stepper motors. We've got stepper motor, a NEMA 17 clone with a lead. You get the 1 meter lead apparently, which is good. 1 meter lead. Also bought wheels and belts and pulleys and some T fixings to go inside it. Right, I'm going to measure this now with a caliper. I don't know the best way of doing this actually. It's probably not the best way, is it? Anyway. Right, so we've got centre hole to centre hole. It is 31, you know. So if you put it to 30, yeah, it's no good. 30, it's 31. It is 31. Interesting. It's 31. Oh, and I also bought these, which are not the right ones. A bag of metal cast, I think they are, corner brackets. These aren't quite as big as the ones that are on this already. So if you're going to buy them, make sure you get the bigger ones. Right, back to it. So we could even model the stepper motor now. Shit. I've We've got to model a stepper motor as well now. Right, okay. Right, so let's get the design done. We'll leave the stepper motors for a bit. So we could do with this on the end of here. Let's just grab that. That, and that. I need to move it a meter. So copy it. And move it a meter, which is bring it in there, but it's the wrong, no, it's the right way around, but it needs to be flipped. So we need to flip it, flip along. Now if you do that, what's going to happen? It's going to totally flip it. That's no good. What we need is we need to do something more than flip it. Flip along the green. No, would that do it? No, that'll be upside down. Blue. No, I don't think any of these. Oh, that's it. That's the one. That saved us a bit of messing around. Okay, so we've got our ends on it. Oh, we're a little bit out because we're out by some amount. Don't know why we're about by some amount. Let's have a look. How far out are we? 2 mil out. Why are we 2 mil out? I don't know. Let's move it over by 2 mil. We're still out. Yeah, we're still out. Okay. So I'm not quite sure what's going on there. See if we can just move it like that. Is that it? Or am I into? Oh no, we've gone too far in. Right, so undo, move. So when we flipped it, we ended up making a bit of a problem for ourselves. 3 mil, that's why. Which is half of the 6 mil. Alright, okay. So we're back there, we're okay, we're spot on. Right. Okay, so we've got our end. Now it's supposed to be, this is supposed to be already 1 millimeter. Sorry, a meter. A meter long, so let's just make sure. Yeah. So there, that's what we've got, a meter long stuff. Now we've got the same problem over here now. We've got this one again. That is. Anyway, so let's. So if we flip that, let's. Well, we'll put one of these. Have I got rid of them all? Why has everything gone? Right, anyway, we want another one of them. Just that. And we might as well have the fixings with it. Because whatever we do, we're going to have the fixings with it. Right, we're trying to. We'll make it first. There's the maximum size we can make it. Right, so we're going to copy that. Paste. in place. No, undo, paste, come out and paste in place. And we're going to move it over by, say 1,000. Right, we'll put it over there. So we need to turn this round now. We need to turn it round by that amount. Right, so then we need to bring that up. That's an upright gantry, so we'll make it this. We'll build it the same at the minute, and we want to grab it by the insides. Okay, and we want to bring it up over to here, like this. Is that it? Let's try it. Has it snapped? It seems to have snapped itself into place. Luckily enough. Lovely. Right, so we've got that. There's our gantry. Oh, we're not quite right. Look, see. Oh, how far are we out? Let's have a look. 2.3. Right, don't know what's happened there. Anyway, let's just grab it. And we have to grab that and grab the fixings. And move it out enough to is that it? Let's try that. Yeah, it's close. Yeah, that's okay. Right, okay, we got it there. Yeah, it's close. Is it close? Or yeah, it's bang on, isn't it? Yeah, it's alright. Okay, so we've got that. Gantry. Now we could go ahead and copy this one. We need to move it over. Move over to there, then we're going to flip along the red direction, and we need to bring it over back again. Easier said than done. Let's see what we can do with it. Get it as close as we can. Alright, let's keep going with it. Keep the red line intact on the red axis. Right, is that where it wants to go? Not quite. Bit more. Let's go a bit more. Is that it? Maybe. Oh yeah. Yeah. You can easily tell if we do that. Is it in? No, a little bit in. Ah, no, we're not in. It's just our nuts are not quite in the right. Our bolts aren't not quite in the right place. Now it begs the question why. These are on, aren't they? They're alright. That's weird. Ah, I know why. Because some of these are out. Are these out? No, they're alright. So where is it out? Which one's out? How can one be out and not the rest? Are these out? No, they're alright. So, are these out? No. So the ends are out. Maybe they're not out. They look out. Let's just have a look at this way on front. Are they out? They are out. Ah, the whole thing's out. Yeah, that's why. Need to go over a little bit. Right, so I need the whole thing going over a tiny bit. I think that's probably wrecked it all. Yeah, it has. Right, let's try again. Not quite there, are we? Let's just measure how far out it is. Let's measure it. 0.27. So I should be able to just move the whole thing. 0.27. And then we should be... No, we're not quite right. Something wrong there, look at that. What is going on? I don't know. .55. Right, has that done it? It's done it, but it's moved it too far over, so we need to now undo that. It's difficult when you're in this kind of mode. Right, so we've still got this problem where it's not quite right. If I could do X-ray mode and move it from there to there like that. Okay, is that looking better? Yeah, that's it. That'll do. Right, okay, so we're in the right place now. Very crucial that we're in the right place. Very, very crucial. Right, okay. So we've got 1 meter by 1 meter. So we could probably do 900 by 900. No. You're not going to do 900 by 900 because this is not centre. Oh yeah, because they set it off so they can put the laser down here. Yeah, so the laser module is as centre as it's going to get. But it could go over more, but then it wants to. Yeah, we'll keep it the same. Keep it the same, won't alter it too much. Right. So you got your laser head sits in there. So you can travel whatever you can travel this way to there. Right, I need some cross member bars now to hold it still. Now that's what these are for. But I haven't got no 2020s, I've only got 2040s. Let's just see These are a bit dark and I can't work out. Could do with making them lighter really. A bit dark looking. These. Can't see the lines. Should have just made them out of aluminium really, forget the fact that they're black. That would have been better. Let's just do that now. Right, let's just colour it all aluminium. Maybe we can leave some black bits on it. Say, don't know. Let's try it. Let's see what it looks like in aluminium. Metal. Is it too much? Might look better in aluminium, maybe. Looks better in black in real life, but for designing it, being able to design it and see what you're doing is another story. Is that it? Not quite. Is that it? Is there anyone else? Is there anything else? Looks, I think it's easier to understand it when it's in this colour, sort of. Is that it? Is there anything else? I think that's it. Right, that's it. Okay, let's come out. Let's hope we've changed it all. Looks like we have. It looks transparent now. It's not transparent now. It looks it anyway. I don't know if that's made it worse or what. Anyway, we'll leave it like that. Now the blue looks wrong. Anyway, right. Okay. Looks transparent now because it's all grey, but it isn't transparent. Anyway, we'll leave it like that. Yeah, it doesn't look. Why does it look weird? Probably better if it wasn't aluminium, just grey. Doesn't, yeah, look, it's making my eye go funny. All the lines in it. Yeah, I can't see the contours or nothing. You know what I mean? I can't. I think we need some. Yeah, I think we need to make some of the stuff darker. Right, so what we'll do is we'll make some of the inner bits darker. in a bit darker, so I'll just use colours and just so we can highlight it, so our eyes don't go stagnant trying to look at it. Does that make it worse? No, it looks better, doesn't it? Right. Does that make it worse? Yeah, too much colour's not good, is it? So we'll leave the underside like that. Yeah. Maybe we don't need. Maybe it's just this one we need to do. I don't know. Or this one. Maybe the underneath. No. I'm trying to make it stand out a bit. No, it's not good. Let's have a look. Tell you what, let's just do a lot of undo in a minute. Right. Redo open, redo paint, undo paint. So what we'll do is we'll just paint these bits. Just so we can highlight it. That's it, just so we can see it. That's better. That's it, we can see it better now. Yay. Yeah, we can see it better. That'll do. Right. Right, looks a bit weird still. Why does it look weird? Maybe it's this that's making it look weird. What about these angles? Don't know. Maybe if we paint these, the surfaces. What's that look like? No, it's not. No, it's not good. Okay. Right, so we. It's just when you look at it like that, I don't know. Oh well, we'll leave that alone now, leave it like that. It's better than what it was, right, okay. Now this blue, I don't know if I like the blue anymore. Anyway, let's get on with the rest of it. So we've got some feet, we've got a carriage. We need to make this. Now we need to get this out of here. It needs to be a part of this. I need that out of there. Needs to be a part of that. So we put these to that, group them, and we can slide it back and forth. Oh, not if we don't put the fixings in, we don't. Right, so okay, that needs to be, the fixings need to go with the group. So I need to cut them out. Cut them out, that's its own entity. Paste in place. That's it. So now when we move this, everything moves with it, yeah. So we can animate it if we want to. Find out if it's going to hit anything. Right, okay. So now we've got to do the overhead gantry bit. We'll have to model a stepper motor, so make sure you've got clearance for that as well. It's a pity the motor couldn't go this side. It's got to stick out this way so the wheel comes out here. Or can that go on the inside? It could go anyway. That could go on the inside, but then you'll lose your cutting area. Sort of, yeah, you will lose your cutting area. I don't know, that's the whole idea of modelling it, so we can find out if there's any better way of doing it. Right, we need some struts going across now to hold the structure. Now do we do them? Do we do them upright or crossways? I suppose a crossways to give it some stability. Then we lose even more. I've only got 20 by 40, so I either put it upright or let's just put one there against it. Let's see. Alright, let's grab, tell you what, we'll just grab I'll copy that, paste it, it's a lot to manipulate when they're long lengths. I should have made it smaller really to start with, and then stretched it out later. Right, so they're all flush. It's flush. And the bolt goes in there. Only one bolt though. This bracket ought to be a bit more elaborate really. We can design that again. Well, why are they... yeah, I suppose it's just minimal amount of plastic maybe. We could make that really auto bolt there as well, and we could sort that out though. Easy enough. Right, so I've got a bit of a problem here. That one big piece is bigger. How can that be? Ah, that's why, because we've lost it here. We've lost that there. So to that end, it probably needs to be bolted underneath. I don't even know if that's possible to bolt them underneath. Yeah, Yeah, you must be able to. You'll have to drill through. Yeah, you have to drill through a hole and then to get to the fixing. I don't know. We'll have a look. How do they do it? Let's have a look how they do it. Do they drill through? No, they put a strut over. That's it. Yeah, there's a corner piece. It's done off the corner piece. So I want to try not to cut these if I don't want to cut them. So to that end, what we could do is lift it up by. Is that up? Yeah, lift it up by 40 mil and move it over by 20 mil, and that should be all on top now. We won't put it there, but that's where it'll be. So they're both things are lined up now. No, they're not. What is going on here? We've got the thickness of this that over travels that. Yeah, so there's a problem as well. You don't want to be cutting it. Don't want to cut it. It also could do with being lower. This, yeah, so we can attach it to the floor. Might not need these ends, we might just use them, I don't know. Anyway, it's the whole idea of modelling it. I'm not sure. I'm not an expert on this kind of stuff. I'm still learning, so we're trying things out. So yeah, so we're slightly over length because that one sits over it. Why does that actually have to sit over it? Why can't that be flush? It could be, but it would need a packer. Whatever that distance is. It'll need a packer, put it in there. Yeah, because we've got to. It's the distance between this gap that you need so it can slide without getting caught. So you do need a packer, some kind of packer. What size is it? Let's try to find out what size the distance is roughly. There is no roughly, is it? It's got to be exact. It's got to be exact. How do we find that out? From this face to... Hang on, let's put it in monochrome a minute. Let's try to find out. 1.5 mil. It's not a lot. 1.5 mil. 1.5 mil that side. It should be the same this side. What am I measuring here? Right, so from there to 1 mil. $1.5 mil, that's it. So it's evenly spaced. So we need a 1.5 mil packer here. Yeah, and the only reason we need that is so the bars can line up, or it'll sit over top. Does it matter if it sits over? I don't think it does. Does it matter that it sits this way a bit? go and check my audio. Sit over top. Does it matter if it sits over? Right. So, yeah, I just like things to line up. And it matters if you're trying to put it in between, then that one won't fit. But then if you turn that round, it was on the inside, then your stepper motors be on the inside. Does it matter if they're on the inside? What? I don't know. I'm not that clever. They're on the outside. Could you swap them round and put them on the inside? And would that get in the way? Yeah, they get in the way because you wouldn't be able to go across. Maybe. So who says your motor has to be there? Your gantry's here. If your motor's in the way, you can't get over. So there's no advantage. So yeah. Okay, so we could do a packer. Alternatively, we could just move it this way. 1.5 mil, and that'll give us 1.5 mil over this way, hanging over. Yeah. So, and I don't like it on the top like that. Although, it needs to stop it swaying, doesn't it? It needs to be down there, really. So, maybe we've got to chop it. Maybe we've got to chop 20 mil off. Well, 20 and 21.5 mil off either end, and slot it in there. Let's see. Let's make it unique. Let's knock off right, let's just go down 21.5 mil off that end. So we've got to chop off ultimately 43 mil off one of the ends. $21.5. Right, okay. So you chop off 43 mil. Then it should be able to sit down. Drop it down 40 mil. And we've got this bit that it joint butts up properly. And you can screw the tab in there, and also need to make one that comes up there as well. Why would you make one that, I suppose on the one I've got, it's only got 20 by 20 instead of a 40, but I'd rather have better structure. Okay, so we could easily do that. Yeah, because we're making it all out of 20 by 40 and not. Oh, you could put it on its end. If you turn it on its end, but then you're losing 20 mil of travel, 20 mil of distance. You don't want that. So I think we'll modify this. I'll just bring that up to there, and we'll just copy that one. Hang on, we'll do it the right way. We'll copy that. We'll copy it. We'll paste it in place. We'll move it up at 20 mil. Alright, and then we'll cut it, paste it in place and push it through. get rid of this line. Come out, wherever you are, and then we've got I need another one of them. Okay. So we've got that now. We've got 2 bolts, 2 fixings, and it butts up, and that acts as a foot and a stay all in one go. So we've got that. Now it begs the question, do you need the corner bracket? Probably you don't need it. Might be advisable to put it in though for strength. That's only plastic after all. You're fastening that to there, then this to that. Might not need it, but we'll put some in anyway. We'll put some in, and we need to model it. We need to model those corner brackets. Anyway. Yeah, because you can put corner brackets in, because by the time you move the carriage all the way over, the laser's going to be here anyway. So it'll never get quite close to the corner, probably. Right, I'm liking it. Right, so we need the same again up this way. So, don't know how far it is, let's just copy it. Let's call it 1,000. And it looks like it's too far. So how far is it? Need to come back 20 mil. Okay. So, are we all nice and hunky-dory? We are. We're missing a fix in there. We're probably going to be missing a fixing on the other side as well. Yeah. Okay, so have we got all our fixings? Probably not. There's still one missing here. Need to get all the fixings in place so we can find out how many we got to order. Right, so we've got a way of attaching it. We've got a frame. Now we do a meter by a meter. Why do we want to do a meter by a meter? I don't know. So a meter's quite long, isn't it? A meter is this big. This big, so I've got a meter long piece just about there. So how far from the table is it? It's quite distance from a wall, so it might be too big, but why compromise? Why compromise at all if you can get away with it? Right, let's just save that. So we now need to make a gantry out of this design here. A bit of a gantry. I didn't have to make this piece because the piece I had was okay, so what we're going to have to do is sort of grab one of those. We'll grab one as it is, we'll copy it and come out of there, and now we're going to paste it. We'll have to paste it here a minute. We'll paste it there, and we need to cut off the stepper motor. Let's have a look at it. It's sort of half and half. Yeah, it's half and half. Is that half and half? It is sort of half and half, isn't it? So we can keep it the same, I think. Let's just stick something like that. That's the same. Keep it as it is, I think. Keep it as it is. It does not look the same. This now looks like it's in the middle to me, but it is because I can throw it out. So we need to make this unique. Make it unique. Into it. Now we need so we want this geometry again. What is this geometry? Coated. Put it there. And we'll just get rid of flip it along the red direction. Push that to here, like that. Okay. Take that up a bit like that. Okay, so we've got that. And there's one side that's flat. There's two pieces to this. So the question is, how far up does it go? Goes flush with the motor. So we can sort that out after, and it's angled with the motor. Yes, it is angled with the motor. So it's angled with the motor. Not sure where, so what we'll do, we'll just go like this for now. Like that, and we're going to lose some of this geometry. Not sure why there's cutouts in it. Oh, for cable ties. I think they're for cable ties. Yeah, there's some cutouts for cable ties. So I think we'll keep the cutouts. Yeah, the cutouts are the same as they are for these. These are the same cutouts. So we'll grab these. I think this is just so you can tie your cables to it, which makes sense because mine are just loose. I've only just made the correlation to find out what they're for. Right. So we'll go into this. Paste in. Paste. Right, okay. Where are we going to put it? Sort of between, in the middle, about so far over. So I'll put it there for now. I'll try and grab it from... Right. I'll tell you what, I'll just measure from there to there, 8.2, so I'll put a line in here. I don't suppose it matters really. Let's just put it in. Let's just put it in don't know, 15 mil. And we'll find the centre line. No, don't want that. Put that in and we'll measure from there to there. Let's just grab them. Keep them parallel, just put them onto there. That's it. That's it, just some cutouts for the cable ties. Right, now we want rid of this stuff. Okay. Right, we're almost there. Almost there. So what we want is a bevel. We need a bevel. Probably that line there. Right, so copy that. Put it up. How do we put that anywhere? $4 mil. Okay. Alright, yeah, another one here. 4 mil. Copy that. Flip it. No flip. Why no flip? Where's the flip? Flip, flip, flip. Where are you? No flip. Okay. Forget about the flip then, forget about the copy. Just go down the 4 mil and we'll just draw a line. Okay, so we've got what we want. Okay. We've got what we want, but it's unfortunately weird. So right, so I want that one. No we don't, we want that one. So delete all that. Look at it face on. Sort of like that, and we want to grab everything out of here. Cut it. Paste in place, cut it. Paste in place, and we need to push these through. Push them through. Oh, shit. No, we forgot. Done it wrong. Undo paste. We first need to make this 6 mil thick. Then paste in place. Then push it through. I'll have to make these holes bigger after. because the milling bit won't be big enough. Okay, so we've got that there. Now we're going to have to colour it right. Oh, it's already got the right face. How's that happened? Oh, it retained it. I thought I would have lost it all. So I've got that. Now this is slightly different one, this one. It's because it's in a box format that goes around it, so the bolts will be longer. So what do we need now? Is we need 50mm long bolts. Right, 50mm long bolts. So we're going to have to make this unique. Right. It's going to have to be made unique. And we need to bring that over from 30mm to 50mm. I'm going to have another one of those. Oh, that nut's going to have to be moved over. That's going to be moved over 20mm. And we want a copy of this one. We know it's whatever it is, it needs to go through 11mm, so copy. And it needs to be 11mm. No. Undo that. So it's 11mm wide. So we've got the 6mm as well. So we've got to copy it and move it. 11mm plus 6mm, 17mm. Right, that's that. Yeah. Oh, where's my nut gone? Where's the nut gone, silly? Hang on, undo copy, undo set insertion point. So that needs to go 20mm. This one needs to go 17mm. Right, so there's our new. Something doesn't look quite right. Why doesn't it? Oh, I know why, because 30mm seems to be 50mm. What's different? What's different? It's 50mm. What size are them? .5mm. Right. Gives you clearance for your fixings, slightly different that one. That's why they make it 7.5mm. Right. Spaces are slightly different on that. I have to worry about that. Gives you enough for the head of the. They just sit in there anyway, it's fine. It's all designed. It's all designed to fit inside grooves and things. Wish I got a chair. One chair won't move. Right, got it. So, anyway, we'll sort that out. So these spaces aren't the same. They probably need to be wide. These are the ones that you can buy, but the ones I've got on it are wider for some reason. Anyway. Right, so I'll keep that like that for a minute. Let's get a copy of this plastic. Right, let's copy it. Let's move it over. How far does it need to move over? So 6, 11 and 6. So you need to move over 6, 6, 18 and 11. 18 and 11. 29. 29 mil. Right. Okay, so you've got 29 mil. I'll sort the other fixings out a bit. Now this one needs to be made unique, because we don't want ability for a stepper motor, it's just a clamp. Oh, this is where the thing fits onto. Traditionally the head fits onto that, so we'll have to alter that a bit anyway. But we'll make it the size. Right, so we'll go into that. And we'll cut it off like that. Just cut it off. Oh no, it's indented. Indented like that. So we want this bit here. Copy. Paste. So put it up there. And we'll flip it. Oops. Flip it along the green. And grab it by the corner. And put it somewhere like that. Is it going to fit? No, it's not. What is going on? Okay, so we want something more here. We want that. Hang on. Let's get rid of that. We want that. And that. And that. Copy, paste and flip it in the green direction and push this down to there. Still not right. Okay. What the hell? Maybe I didn't make this as well. Oh yeah, maybe I didn't make this as well as I thought I did. Okay, so what we'll do then, we'll do it a different way. We'll grab that. Copy that. And get rid of that one and paste. And flip it. Flip along the green. And we'll see if we can get it to fit this time. Is that it? Must be. Okay. Right, yeah. Yeah, so it's a little bit out on everything. Okay. So let's get rid of something else. Let's get rid of that. Don't need the hole for that anymore. I don't need the stepper motor holes. We don't need that. I didn't ignore that. I can't get over no more because I've got No surface to scroll against. Right, what have I got now? I can't scroll out. Right, I've got a bit there to get rid of. Okay, right, let's have a look at it sideways on. What we're going to keep, what we're going to get rid of. So, hang on, front ways on. Sideways on. Right, so front ways on, we need to get rid of something. Doesn't matter which one, doesn't it? Yeah, the one that's intact. We need to keep the one that's intact. So get rid of the ones that's not intact. Have a look at it. Right, it's all there according to that. So we need to just come out of it a minute. Have a look. Right, it needs to come towards me. I can't get hold of it. Right, so I can go back into parallel projection. So it needs to come to me 6mm. Okay. Oh, we've got no surface now. Why have we got no surface? Let's just take something out and put it back. Maybe we'll get a surface back. Yeah. Okay. Let's grab all this stuff. Cut it. Paste it in place. Cut it. Go into there and paste it in place. Push it through. Oh no, we don't want to paste it in place yet. Undo paste. We need to make it 6mm thick first. Then paste it in place, then push it through. That was wrong. Then these. Okay, we come out of that now. Now we've probably lost our colours, I would have thought. Yeah. Let's have to select everything now. Right, let's get a few more. A few more, it's got... Oh, pressed the wrong button, I've done it all now. Shit. Right, I'm going to start all over again now. Oh, hang on. Or is it undo? Undo open? No. Right. If you get the wrong symbol, you have to start again with your select. Cancels your selection out. Pain. Just do that one. Right, there's still more to do. tedious thing. Tedious. Okay, where have we forgot? More of them. Pain in the ass. Why doesn't software examine what you're doing and ask you if you want it to do it for you? Should do, shouldn't he? I can see what you're trying to do. Would you like me to take over? Well, yeah. Take anything that's tedious. Do it yourself. Doesn't understand patterns, does it? It's too old, the software. An operating system should... Maybe the operating system will be able to see what you're doing all on its own, regardless of software at some point. And say, instead of Microsoft doing telemetry, they should put blooming some decent stuff in it. Oh, I can see what you're trying to do. It does it with spell checking, doesn't it? Does it with spell checking. So why can't it do it? It can do it. It will do it at some point in the future. Not quite yet. Unless people rebel against it. Because they want to do it themselves. They want control. At some point they're going to lose control. It's already happening. Right, so I've got now this other piece. These models are probably already out there, but you can either spend your time looking and not find them, or you can... Yeah, so these spaces need to be different size. Right, let's make them different size, so let's see what size they are. 8.2 mil. 8.2, that's nothing. 7.8, so let's say in between the two. They're 8 mil. 8 mil, so what we need to do then is come out of that a second. Create, make this a unique one. Right, so it's unique and it's 6 mil, it needs to be 8 mil. Make it 2 mil bigger. That's alright there. So we need to lose, actually we need to do something here. So if that's gonna, this whole thing needs to go over by 2 mil. No, plus 2 mil, 4 mil. 4 mil over. And we need to get rid of this one now. Need to copy that over to here. I need to get rid of that one. Then we need to move it over by 2 mil. Have a look at that. Oh no, something's not right. Did something wrong there. Undo. Undo, undo. Oh, because I've moved that over, haven't I? Why have I got 4mm there? Made a mistake. Made a mistake, so keep going back. Need to move it over by only 2mm. And this one needs to be copied over here. What the hell is going on here? Now it's gone stupid. Click on the wrong thing and it all goes stupid, right? So we need to copy that, put it there, and delete that one gone. But then we need to move that back by 2mm. Right. Okay, so we've got our wheel, we've got our spacers, still got a bit too much play there. Because I'm not using 7.5mm, I'm using 6mm. So you are going to get a difference. But the surfaces will be the right distance apart. That's fine. So let's move this back. How far are we away here? Let's have a look. Two mil out. Right, okay. So let's move that over by 2mm. And the nut over by whatever that is. Oh, why haven't we got a hole there? Missing something there, geometry. Anyway, I'll sort that out in a minute. Alright. So we've got this here to there. 4mm. Move that back by 4mm. Okay. So now we've got a weird thing going on, that the 50mm is too long. Well, it's too long because the plastic 6mm longer. So we're using 6mm and they're using, what are they using? 9mm. 8mm. 8mm plastic. So we're 4mm out because we've lost 6mm out plus a little overhang. Yeah. Why does that nut look way too small for that? Something must be wrong. Anyway. Well, I'm making it slightly different, so we could lose that. Let's go back. Let's say 4mm. What's that look like? Still too much. What's better? Right, that'll do. Right, that's okay. Right, so we're modelling this thing. Now I need to get rid of these other wheels. Let's get rid of them, and them. Copy that down. We already know it's 31mm, so 31mm. No. What is going on? It's not 31mm. Hey. Undo. Copy down there. No, it's not 31mm. Why did I think that was 31mm? Don't know why I thought that was 31mm, I'm sure. Let's just have a look here. 60.5mm. 60.5mm. Alright, so we're going to move that down by 60.5mm. And I think they were different again. 64.5, wasn't it? .5. No, hang on. Don't know what I'm measuring here. Right, let's try again. .5. 64.5. Right. Okay, so we've got the thing in place. Yeah, that's it. No stepper motor on yet, but that'll do for now. So we need this to be all one piece. Okay, so that needs to come. Hang on. Oh, it's all there anyway. I don't get it. Hang on, why is it all there? Hang on, let's just move it. Yeah, it's all contained in. That's okay. Alright, I just need to see what's happening. Okay, give me a second. I've got to just pass a message on. Let me save that. Right, back again. Time is it? 9 o'clock. Right, so we've got this carriage. I'm going to put stepper motors on after as well. When I model the stepper motor, but I need to turn it the right way around to go on the gantry, which is, yeah, it looks like it goes on the back, so it needs to spin. I need to spin it round. I need to spin it round sort of like that. And we need to get it onto the gantry, so I suppose the easiest way is to grab it by one of these corners and just literally plonk it on. Plonk it on. Right, is that on? Oh, no, it's a bit too low. Still too low. What's that like? Better. It's better, but it's not quite right. That's alright, I think. Close. Close. Let's just check the bottom. Checking the bottom, yeah, looks good to me. Close enough. Close enough for Australia, as they say. Australia. Why do people come out with derogatory remarks? Everyone's got to have a derogatory thing, haven't they? Oh well. Right, so we're on there. There's enough clearance for the screw heads for the stepper motor. They don't actually line up. Is that the screw heads? Hang on, that's not the screw. Yeah, it is. No, sorry, they're up in the air. What was I looking at then? Oh, they're not the screw heads for the stepper motor. They're the screw heads for the laser, the diode laser. So, oh no, they're not the screw heads anyway. These are there's no screw heads on it. So we're gonna have to put. We're not having a diode laser on it, but right, let's just go on to this view a minute so we can have a look at this. So there's your diode laser that normally go on it. It's fastened. How's it fastened in? It must be. Didn't I buy a spare one of these once? I don't think so. It's got 4 fixings on it. So I suppose I ought to take it off really and model where they are. Or see if you can buy one online, a spare one. Don't buy it, but see if they have a model of the fixings. Anyway, that's the idea. Right, I'll just check my phone a minute. It's pinging going on and all sorts going on here. Right, okay. Anyway, we'll leave the fixings for that for now. We will have to put something on it. We're not gonna put a. Well, we might put a small diode laser on it, but as far as I can tell, they're no good for cutting plastic, thick plastic. So on the back of this is going to be attached to CO2. But effectively, you could turn this into whatever that is now, but a lot bigger area. Right, so I think we need to model a stepper motor in a bit. Now, this is the frame that moves. And there's also got to be a frame that holds the diode attached from this. all your mirrors have got to go on here. So your CO2 is going to have to be attached to this back here as well. It might not be across there, it might be on a piece that bolts to it, a piece of angle or box. I quite like the idea of having it all visible. So we're going to have to model a diode laser, a CO2 laser as well for the size. It's never ending. Yeah, you can go to the warehouse, extension warehouse, if you want to sign in and all this kind of stuff. Maybe you'll find one. I don't need an elaborate one, I just need something that approximates the size for the fixings. Right, so we've got that. That's quite sturdy there with the fixings both sides. It begs the question, why don't they do the same this side? What is the reason? Is there a reason they don't do it this side as well? Why don't they put the piece there? Or is it because there's something in the way? Maybe they don't know. Or do they want to attach the bed to this? Maybe they want to keep it free. And this is quite high up as well, so all this will have to be altered. So you have to mount your CO2 laser head. Have to be, at least plastic might have to be increased to accommodate that. All sorts of stuff. Anyway, right, let's bring back the case. Right, so we're totally upside down and wrong way around now. Right, so we've built it in reverse for some reason. Let's spin the whole thing round 180 degrees. No, not that way. Just like that. Put the case back. So you can see the problem we've got. This doesn't fit in the case. Doesn't fit in the case. And it's quite wide, 1 meter wide. You'd have to lean over, but you know, I mean, you could bring it lower, cut these smaller. It's tempting off the back to make this exactly the size they come as, but we won't do that. What I want to do, what I was thinking of, is sounds mental, but take the bottom out of the case. Totally get the bottom out of this case, because the size is about the area you want to cut. 700, say 711 by 500. So yes, you can lose a mil of the metal. Well, basically it'll pass off as a hood. Pass off as a hood, but you still need to keep oh, I seem to have lost my... Right, okay, so I put them all under case, haven't I? So I need to delete them, cut them off. No, we need to keep that. So what we need to do is the other way around. Undo close, undo open, undo cut. We need to make the case. Right, so we've grouped. Have we grouped them all yet? No, we haven't. Need to group them all. I thought I did this. Group them all. Alright, that's part of the case. Right, let's change that. So that is front, left hand front lid. Right hand front lid. And rear lid. Okay. Right, so turn off the lids a minute. Have a look in. So this is what we got. Now, quite possibly, what we want is a hood, but I want to keep all the electronics in there. So, right hand lid. All the electronics I want to keep in there, but I don't want it on the floor. I need it up in the air, and there's a lot of space in these. So it needs to be raised up, basically, up there, out the way. To leave room for, you know, put all your power supply here and your electronics. And leave the space for the bed to fit in, around there. But I don't want to fit it in. What I want to do is, basically, I need this all we want is the gantry here and the laser. This needs to move around. Now we could alter that if we need to. We could alter it down a bit. We could do different things with it, but we'll leave it where it is. Keep it standard as far as we can. I'm thinking I want the 700 by 500 space. Definitely want it. Let me just check the audio. Yeah, mic plays up sometimes. So I want this as a electronic container and the hood, the smoke hood. So if I make this, keep this, so the cutting area will do 700 by 500, which will make this stick outside the box. That's okay. It'll sit outside the box, so we could take the box up in the air a bit, actually. Tell you what, let's take the box. Yeah, so whatever we do, it's going to have to sit higher than this. Now if we add the other piece there on the inside here, we could attach that to that piece and fasten it there, and you could have it almost have it flush. Sounds crazy, but then your mirror would have to stick up a bit. I only want to be cutting plastic with this, so I don't need a great big length, massive ability for the bed to be lowered and raised a lot. I'm only looking at from the focal length about 20-30 mil. That's all I'm interested in. You've probably got that there already. Already got that there. 40 mil. You've already got 40 mil clearance on that. Enough for the things. I think a low profile version of it. So you still need this bit. You still need your stepper motor. So he's going to stick up a bit.
Hello, CQ12, CQ2 from
But
Mike
that,
0, Whiskey, Yankee Zulu, 0W.
But that could be turned around so the stepper motor's below. We'd have to model the stepper motor. So imagine this space here is your stepper motors moving up and down here. You've got to make sure you've got a drag chain to put all the stuff in. The air assist and the cabling. Got to make sure that all works. Now if that was flush with this, still your mirror would stick up slightly. CO2 laser would have to sit. We'd have to model the laser as well, and model the mirrors, everything to get this right. I reckon what I was thinking, you want to contain the smoke. Smoke rises. Hot air rises. So you have your So let's say let's first put this flush with the floor. Hang on. Let's put our axes on. Let's get this flush with the floor. So let's put the case up in the air a minute. Let's put it up, I don't know, 200mm for now. 200mm. Weldon Gillespie, I went to Carriage, it makes things so smooth. Worth a look. Carriage, welcome to the stream, Weldon Gillespie, how you doing? Carriage, mate, I'm not sure what Carriage is. Is that a technology? Different way of doing stuff? Make things... Or is it a program, 3D program? Maybe that's what you're on about. I know sometimes the playback is... to me it's looking smoother, but when it captures it sometimes it's a bit... I don't know what you're on about that. Let's Google what you're on about. Carriage. I never heard of that, I must admit. Carriage. Right. Carriage. Okay. Removes weight from the moving axis. Oh, they like motion using 3D print that allows for faster and more precise printing. Is it like a linear guide rail? Is it like one of these? Hang on. What did I do with it? Picked this up yesterday actually. I paid £1 for this. Don't know if this is what you're on about. Linear guide rail. Is that what they call them? Yeah, these are. There's a load of ball bearings. Can you see them? It rides on a load of ball bearings. I don't know if that's what you're on about. Weldon. Removes the weight kinematics. Motions. 2 motors control the motion of both X and Y. Okay, so you don't need 3 motors, you only need 2 motors basically. This thing here has got 2. It's got a motor on both ends. Stepper motor there, and one there, that's it. But I think they're just wired in parallel.
Hello, CQ, CQ12, CQ2.
They're wired in parallel.
0WYZ calling on a singular.
I just picked this one. This was in a... I don't believe where this was, in a charity shop. Charity shop, that was £1. I picked up for £1 as well a mechanical keyboard. That was a good buy. Anyway, one on its own is not much use. Two motors control the motion. Can use the wheels too. Motors go to end of Y and belts move. Yeah, got you. I know what you mean. Maybe we'll get to that at one point, but the kind of accuracy I'm looking at is it's not for 3D printing so much. It's just basically milling out plastic. That Amiga case there, milling that out, and if I can get 0.25 of a mil, I mean they're pretty accurate. The CNC I got is accurate to 0.04 of a mil. It's got ball screws, but when you get things happening, the head moves, and as you're putting pressure on, and your material moves if you're sticking it down slightly. So the accuracy is never that brilliant, but I'm not sure if this will be accurate enough, but it's a building block building block. I was just going to buy another bigger laser. I just need to be able to cut the panel out in one go. Interesting to know though, yeah. Yeah, gotta keep up with the latest, all the latest stuff really. I made my K40 Carriage so much faster and precise. Alright. Yeah, sounds good. What I'm trying to do is increase the bed area at the minute. 300 by 200 is not enough. The panels on these Amigas are 500mm wide, and I want to do the case, cover and lid and base in one piece. So I need a front loading and rear loading pass through on it. So, but I've got 3 of these K40s now. Picked up another one the other day. So I've got a choice whether to... I don't like the idea of fetching all the electrics out. And then you go passing high tension cables through a hole. Or directly through to the... You know, I just need to be grounded really. But I think we can raise it up and still be able to keep everything out of the way and have the range of motion on the, you know, the amount of, just the bottom of it is 700 by 500. That's what I'm after. Now I don't mind if this mechanism has to sit outside this, I don't mind. Say for instance, I'll tell you what, we'll lose the base. Can I lose? Yeah, I'll lose that cover there. I'll lose that. Basically, I don't mind if I have to cut the bottom out of this K40. Basically, I don't even know if I need it because I could make the whole thing out of plastics like I've done with this case, and make the structure out of. You know, bolt it all to... I've got loads of this stuff. I've got 10 lengths of this. So that's 5 lengths used. And there'll be some... If I make it to just do 500mm, I'd have these offcuts as well. And a few more offcuts for building structure. Bolt it all together. I can't... It's difficult to explain, but... tell you what we'll do. Let's get this onto the ground level for a start, and the way I do that is I'll have to grab the whole thing. Now the whole thing isn't contained, so let's grab the whole thing, make it a group. I need to push that corner over to there, like that. Yeah, I'll have a look at that in detail a bit later, that correct, see what it is. I've got a 3D printer, I never even built it yet. I never built a 3D printer. Never built it. Right, so I need to push this. We need to get this over somewhere. I suppose I'll tell you what I'll do. I'll put a line here. And go over, if I can get out of the way, we'll go over 50mm and we'll come back 50mm and we'll put this, just need to start from an origin. So it's in within the border of everything. Yeah, that'll do it. Right, okay. So we've got 50mm there. I can now lose the axes out the way. Yeah, so I might not use this at all, but you still got to put your electronics somewhere. You still got to have your water cooling. I suppose if you had it, you could still keep your laser tube in there and everything. It doesn't make sense really, but I mean, imagine if everything was out. There's nothing here. All this is just empty. There's no bed, there's no nothing in it. It's just a hood basically that holds your electronics and holds your laser tube and your extractor fan, and it needs to sit over top of here. So to that end, let's move the thing over there. Let's move it over here. Let's put it on. It's not going to be this low, but obviously it won't be this low. Right, so it's going to have some clearance. I can't see what's going on. Yeah, it's too big at the minute, so I really need to resize it to what we want. This is just going crazy. It might not even work, but I haven't thought about it into too much depth, nested. Just because I'm going to design something anyway. If we have to modify something. So basically I need the range of motion. So this needs to sit outside there, so it needs to sit over a bit like that. And where this hood needs to sit over, doing this in a different way to normal. Needs to sit something like this. So it makes sense for this to be level, all flush with this. Yeah, I think it needs to be flush. Well, so obviously it can't pass through there, but if it was down here, it could pass up and down. The focal length, it might have to make these legs longer to get the material, the space for all the material and the space for the laser head or the mirror and the focal thing. We might even have to make, yeah, we're going to try and keep the laser head the same if we can. So let's modify this then. I want to keep these because I'm going to use these if I get broken parts, so I don't want to. Well, what we might have to do is save what we've got so we can keep these bits and use them, then modify them. Because this will be rolling outside, but if the other side of this is on, stepper motor's here anyway, it's all on the outside. So got the maximum space from the inside. You can either do that or you could I think the smoke, I think if you got a powerful enough extractor fan and this is off the floor, obviously it can't suspend in free space. So this would have to come down parallel. So let's do that then. Let's just at the minute, what's it look like in there at the minute? It looks about the right height and that, but if you look into it, it's sticking through the thing there. Yeah, so what we'll do, we'll hide the case a minute and we'll just concentrate. I want to keep these brackets because they are actually modelled to do that other job, to fix those. So I'm going to save this. Save it. I'm going to save it as something else. Save as I'll just call it old gantry. Old gantry. I'll keep that like that, and we'll bring back the new one. Right, so we've got them, so I'm going to modify that now. If that only bolts to there, your stepper motor is on the outside, so it doesn't matter, but we need a piece like this on the inside that holds this gantry and moves it up and down just like that, so it's flush. I don't know, maybe I'm going crazy, but the mirrors, the CO2 obviously in the case, it's probably, the case is not a good idea, because the only way this works is if you mirror your tube is level here, wherever you're going to have your mirrors reflected. You don't want more mirrors if you don't need them. It's nice to have it covered. I don't know, maybe I'm just going mad. Three hours 40 minutes, 9:45. Yeah, I've got to make a move in a minute. Right, we'll have to carry on with this later on, I think. So let's try and think about this. So I always look back at the video overnight and think of different ideas or where something went wrong. But it needs to slide up and down there. It needs to have a stepper motor on it. A stepper motor could be turned around, and the motor could be put underneath. Yeah, so that could be put underneath if need be. There's enough room for the stepper motor. If we don't have this, if we have it on the side. So let's try it. Let's try it. So we want what's that? Oh, we got someone transmitting up there. Right, so I'm just trying to get my head around whether this is even worth trying to do this in this way. So that can be put here, and it can be moved up and down like that. You need enough. It would have to stick up a bit, so the beam would have to pass over top of this. It can't if there's a gantry in the way. But if that's held from the bottom, you'd have a clear ability. I don't know. I'll try to keep it the same as this thing we've got here. I suppose we better model a stepper motor at some point. Could do with making the size the right size as well, but I mean, it doesn't matter for now. We can easily sort that out. So this is what we got, a working system already with a diode laser on it. And we want to convert this to work with CO2. So I envisaged a bracket bolted off here, part of this, or even this. Maybe we bring the whole gantry forward like this. Oh, that's not part of that now. Hang on. Right, let's make this, cut that. Paste in place, so we'll make it part of that thing. So we can move the whole thing forward. Like that, out the way. And somewhere bolt a bracket or box section, or just the tube straight on the back of here. So this is the area we're looking at really. To that end, let's bring this forward. Something like this. Something like that. Yeah, just making sure the lids. So this basically. So we need a material pass through. So if we could put this is on the table. You got your material pass through. your focal length is set to 20 or 30 mil above the table. I suppose we could put a table in. Could make an IKEA table, I suppose, but let's leave that for now. So obviously that's not going to pass through there, so it can pass underneath. The CO2, the mirror. At the minute we've got a mirror in here, a hole there and a mirror. Got lasers that way, 45 degrees into there, which then goes onto a mirror onto there, which 45 degrees out to the gantry, which 45 degrees down again to the material. So you got 1, 2, 3 mirrors. 3 mirrors. So not sure what would happen if you had 4 mirrors. If you had 4 mirrors, I don't know what would happen. I suppose you could rearrange your 3 mirrors. You could make it point down. Point down, so your mirrors move with it. So if it pointed down instead of across, point down, and 45 degrees across to this one and that to that one. You still end up with the same amount of mirrors. I'm sure you end up with the same amount of mirrors. Instead of it coming out, no, you'd need another one. You need to go down. The mirror would be facing down. You need another one here to go across. You need 4 mirrors. I'm not sure if adding another mirror is a good idea or not. More mirrors, the more to keep clean, the more degradation of the signal, the laser beam, maybe. So anyway, but we could take the tube out and mount it on the back here. Mount it, fasten it to the back. Put your clips on here. Fasten it to the back. Because this, well, you don't want to run that all the way up here anyway. As long as you can cover the area we're trying to do, 500 by 700. So this can be used as a mechanism. Limit switches can go here, everything. This can hold your laser tube and your box of electronics. So what is the point of this thing then? I don't know if there's a point. Don't know if there's a point. You just hide it a minute. Anyway, we've done a lot of modelling, so we'll leave it at that. We'll ponder over that before we make any major changes. Ponder over it. See if I do this. Look. If I move it that way, 300 mil, and move it that way, 200 mil, and move it this way, so 700 mil, right, and come out of it, and then I can do an undo this little, like a crazy bit of animation, but you can do animation anyway. Right, let's have a look at it in monochrome, bit more visible. Right, so we've got the basic structure, the belts and motors. Don't need to worry about them in a minute. I will model later on some more stuff, maybe tonight or later on this afternoon. Got a bit of a deed to do, got to drop off some stuff and go out and about, so we'll be back again. We've got a meter by a meter. Nobody really wants a meter by a meter. That could be smaller, but if we want to bolt stuff to the front and back and still keep our area, our work area, and this can be used for structure. You can bolt all your stuff into there, controls, everything. Your tube. So it looks like I'll be modelling the tube, the power supply, then the mirrors and all sorts of stuff. So it's a bit of a Frankenstein thing. But I want to be able to have the ability to pass through your work underneath. Sit on the desk, push the plastic sheet through, and the plastic sheet, I think it's 1 meter wide actually. So I don't know if you'll be able to get, will you get 1 meter under there? Let's have a look. That's not the one. Can you get 1 meter across there? No. So you still can't. What I hate doing is having to cut the plastic down first to manageable sizes. Anyway, that's gonna be it for today. Let's find let's have that as our whatever it is. Don't know. Anyway, it's all anatomically correct, give or take fraction of a mil. Alright, that's going to be it for now. I've been going for 4 hours, that'll do it, and I'll be back on this evening. Thanks for participating, anyone else, and be on later on. I can't build anything until I've got the design that I want before I start chopping stuff up. Alright, I'm out of here. Thanks for watching, and bye bye.
The most logical course of action is to transport me to safety with all due urgency.
That information is not available.
Korak, what are your limits?
They have not yet been defined. My knowledge is virtually infinite. My secondary ability is to logically process that knowledge and make accurate predictions.